problem, but looking at this equation, is anything the equivalent of y? Is that a y, the y variable though? So we need to be careful. That's not a y variable, that's a y, y intercept. Okay, we can get to that in a second. F of x though, is that the same thing as a y?
Yeah.
Because when we say y, what we're talking about is the output, which f of x is an
Input.
hold on. We need to remember, f of x, which part of that is the input? That's the input. And so it's not the f of x, the whole thing is my output, right, slash y, right? It's not just the f of x is my output. When I say f of x, that whole thing is the output. It just allows me to use function notation. So notice f of 0 was equal to negative 4.55. An input of 0 gave me an output, the whole thing, of negative 4.55. That's the beauty of function notation. It shows input and output at the same time. So I'm going to substitute 0 in for y, or substitute 0 for this equation. For what? Substitute 0 in for what?
The x.
The 110's up here, bud.
I was just repeating what you said.
No, but
I didn't say that.
No, not you.
Come on, the 4.5.
0 and
Hold on.
y.
What did you say?
The 4.5.
Now we need to be careful. Is that a variable? So it's a good thought. But remember, this is a thing we have to be careful about. Is that a variable? So can that change? So can I substitute it in there?
No.
Remember.
X.
Hold on.
F.
No. Hold on.
Stop.
Just hold on.
There you go.
Okay. So we go with the fact that that's a y-intercept. That's not going to change. I can't substitute anything in for it, right? Is that 0 is y, correct?
Correct.
So am I going to substitute it in for x?
No.
No.
You're gonna substitute it in for y.
But there is no y in this equation. So what's it?
F.
Not f.
F
F
of
of x.
You just talked about it.
Well, I said, well, I
F
said
of
F.
X, man.
But it's not f. F is not a thing. F of x is the output.
He just
Remember,
said it.
the f of x, the entire thing, is my output or y. If you don't think about it that way, you will mess up when solving these equations. Okay?
I had it.
It has to take the place of the entire f of x.
So if I was to put it's taken in for y, I would get it wrong because it ain't no y.
No, you would get it right, but I'm saying that you might forget that that y is the same thing as f of x. And if you're saying substitute 0 in for y, and you're looking at this equation, you might get lost.
So
Which is why I'm trying to make sure we understand that f of x is y.
So what is the x?
It's x, dude.
Bro, I'm saying, don't we gotta put 110 for x?
For this problem,
Not for the bottom.
these are different problems. Notice we're going to substitute 110 for x here, but we're also going to substitute 0 in for x. But here I'm looking for an x-intercept, which means y is equal to 0. So that's a different problem. You can't mix those two. You got to do two different things for those two different problems.
So basically, when we write the problems, they'll put F of x. We gonna put F of 0.
No.
Or no, you just gonna put 0.
Right.
And then do.
Notice I said substitute 0 in for f of x. Not for x, for f of x.
Which is y.
Correct.
And then you just put it in the capital.
So basically,
Well, you have to solve that equation,
Yeah.
but
Okay.
now, hold on. Y'all are going to work on completing these two within your small groups. Quick show of hands if you think you understand what we're going to be doing within our small groups.
Oh, no.
Yeah.
You just explain it, okay? No one here understands what we're doing?
Oh, no. Yeah, come on, man.
What do you mean, 110, that's my what? X! That's it! So what's 110 gonna get substituted in for?
X.
X. 0 is,
Substitute in for fx. So you put 0 equals 0.065x minus 4.55.
correct.
Alright.
For the first one.
No, for
The
this
second
one. 0 in for f of x.
So what do you put? You put 0 for,
Please write it on the board.
For x. No, I want y'all to do this. You have to be fast.
for the first one.
What does it say? 110 is my what?
X.
You are,
Right,
you
so
should have
110 is gonna get substituted in just for,
X.
yes, this is why we need to keep in mind our variables.
Jesus.
Let's, look, I'm gonna be here to support you. We gotta start doing this within our small groups.
I did that
There should be at
already.
least one person in each group that understands a little bit of how to get started.
F, okay then.
Oh, now we finna have to
Zero,
say
zero,
zero.
0.25.
It does help. Okay, right? So you substitute 110 in for x. Now simplify this to know what f of 110 is.
Me and math have a little struggle.
It's Kenny.
On the second, every No.
Okay. But that's why we stop so y'all can talk within your small group. So let's talk, let's get that work going. There's at least a couple of y'all that understands in that group, talk with each other.
That means we have to do this on each side.
Don't say y equals, that means kind of correct. But remember, we're using function notation for a reason. My point is you shouldn't have had f of x. You substitute 110 in for what? So you should have said f of 110 equals that.
Oh, okay.
Does that make sense? What you showing that? How's it going over here? We talking with each other, trying to figure it out, make sense out of it? Lightsabers. I like it. My wife had it for me once upon a time.
Go ahead, add that to both sides first, and then see where we're gonna get you.
So remember, we're trying to use
After you do that, think
the linear model to figure out that. Figure out when x equals 110, when x equals 0. It does not seem like we're all on the same page. Come on, remember, we gotta talk about it, make sure we're all on the same page, making sense out of it. Let's get started. Talk with each other about that
Okay,
one.
so now
Don't
we
forget to do the one before it. Kyle, are y'all in the same group? Kyle, you got people to talk with right here.
I wanna know, wait,
So
before I
we
finish
did
first.
this
Yeah.
Let me finish
both
first.
sides.
And then I'm gonna ask you.
I don't want you to ask me, I want you to talk with each
Because
other.
I know, but I'm finished and I wanna know.
Then talk to the people in your group.
They don't know. None of them
I mean,
know.
Brittany's got an answer. I don't know if it's right or not, but if y'all got the same answer. Oh, Dawson has an answer.
Okay.
Caleb, do you have an answer? Oh, you guys have started to get an answer. So don't ask me, talk with your group.
No, I did.
I forgot,
Now, don't forget, if your answers are close, then you're probably right, but you probably have different y-intercepts and different slopes because you all did it on your own.
See what you get. What you get.
Did you use the same one I did for N?
Yeah, cause that's, we was the same.
Oh, that's true.
So since I got 70. Let me see. What did you get?
So look, talk about it, look at it with each other.
Oh, that's because you added it. You got the added.
And this.
Oh, so that's, yeah, I did. I did, but you don't add the X.
Where's your sheet?
It's just why I said, it's like if you was yeah, like that. Oh, you do minus B minus B. Yeah, like that. And then cross out that you 0, whatever that is.
I want Ishmael. You have lots of good ideas, but you're not talking.
Divided by this.
I appreciate the talk. Keep it going.
Whatever that is. Oh, okay.
Michaela, how's it going? You finished? I don't see x equals on that last question. Have y'all just not gotten that far yet? Keep working.
It wasn't hard, but I
What do you know about every x-intercept? The y value is 0, right? So if you substitute 0 in for y, so now you need to figure out what x is.
We're gonna have different.
Look at that equation.
I still be stuck by speaking. but
How would you figure out what x is?
Ooh, hey,
It's
Miss
a really important question word that you might want to
That's the last, we're talking about the first one, you said we Yeah.
remember, you're trying to find what makes that equation
I got
what?
this spell.
True? So how do you do that? There's an important estimate. Not slow, good idea. But remember, how do you find what makes the equation true? What do we call something that makes the equation true? But it's not something on here. It's something we've covered heavily in the past. What do we call something that makes an equation true? A solution. So what do we need to do to that equation? Which is called solving it. How would you solve that equation? Good.
Can I answer the
When we
second one?
finish, can I come up to the board and write it?
Yeah, let me write the second one.
No.
That is right. Do you want to know what it is?
I wanna do the second.
No, you don't know what it is.
Yes, I do.
What is it?
I'm not gonna say it out loud.
What is it?
I'm not gonna say it out loud.
Thank you.
Yeah.
Thank you. Okay. So, how many of us substituted that 110 in for this first question?
Me. I
Makes
did.
sense?
Yeah.
Because what is x?
110.
110. Do you have to make it more difficult than that?
No.
No. Don't forget, it's 110 degrees Fahrenheit. Temperature was in degrees Fahrenheit. Now I want to pause for a second. There is something wrong about what I wrote in that equation. Does anyone see it?
Wait a minute. What equation?
Say again. So like I was supposed to put the 110 somewhere over here?
No, that's right.
I'm telling you there's something wrong.
You're supposed to put the 110 in for.
Oh, you put it in with.
Oh, so I need to put it here as well?
Yes.
Chelsea, what?
Yeah.
Yeah, I wasn't saying you're wrong, but other people are still getting there. So, I need y'all to remember, do not write f of x when you're trying to substitute that 110 in for x. We are literally saying that x is 110.
Yeah.
Now, I saw some people showing some work here, but guys, don't you have a calculator to simplify this expression? Could you type that entire expression in all at once?
Yeah.
So f of 110 is equal to what?
Hold up, cause I'm having to redo it. I forgot to add the 110 in. 2.6.
Oh, if it's,
2.6?
oh, it's the same thing.
Yeah.
Yeah, I got 2.6.
You just had to make sure that 110 is right there as well.
Okay.
Any questions?
And then you divide.
No.
No, you done.
No, you done, bro.
So you trying
So
to
why
pick
you put
one?
110 right there for you could just put alphabet?
No, you can't. Because what took the place of x? So 110 had to take the place of x.
So you're not gonna solve it.
There's nothing to solve. This is function notation showing that I have a point. What is the x value of my point?
0.2.6.
No, your point is 110.
The point is not 110, the
The
x is
yeah, you
110,
yeah, that.
and the y is
2.6.
right.
Oh, so I had the right answer the whole time.
Notice, we aren't solving anything. Remember, is f being multiplied by 110? Because that's what you're thinking about, isn't it? Is f being multiplied by 110? No, it's f of 110, f of x.
Cause I thought it was being multiplied.
But this is why we need to understand function notation.
See, that's why I can't be second guessing myself. Cause I was right.
Any questions up to this point?
No, sir.
Can I go
I got it now.
Huh? Can you go home? No. So I want to point this out, right? I'm not going to write it up here because it wasn't part of the problem. But what does this point actually mean? 110 what?
Degrees Fahrenheit.
Degrees Fahrenheit. So at 110 degrees Fahrenheit,
The
The
concrete.
concrete expands 2.6.
2.6 what?
Feet.
Feet. Right? There's meaning to these numbers, which is why we need to interpret the variables to start. At 110 degrees Fahrenheit, the concrete expands
At 2.6 feet.
2.6 feet.
At
That's what's happening there. There's meaning to these numbers.
the concrete expands.
I'm loving it. Write it down. At 110 degrees Fahrenheit, the concrete expands 2.6 feet, right? There's meaning to this.
Oh, that's a straight line. I've never done that in my life.
That one? Is it?
Yeah.
Straight.
Cool. I've never done it either. You get lucky every now and then.
No, I've never did. My
You also have to remember I've been writing on a whiteboard for
You,
13 years.
how old are you?
8 years.
You old?
I mean, I'm 30.
Oh, that's not.
Alright, now Mr. Kenneth.
I used to think 30 was old, but. So, I'm not going to show the work for this one because we've already done this one.
Not either. It give you the same thing, yup.
Well, it gives me the same as this y-intercept.
Yup.
But notice again, am I multiplying 0 by f?
No,
No, that is my what?
Why that? Wait, what?
This is known as what?
yeah.
Oh, yo.
Replace X.
What is this notation called?
F linear function.
No!
Function notation.
Yeah.
Right. Remember, function notation shows both my input and my
Your output.
output.
So you can put it in parentheses, input, output.
So-
So like as a point, yes.
Yeah.
Kenneth, I thought it was 0 equals 0.65.
Hold on. You're mixing up your variables, which is why we have to define our variables. This 0 is what? Degrees Fahrenheit. This 0 that's getting substituted in for y, what was our y again? Feet of expansion and contraction. This 0 is going in for f of x.
Can I come
This
to the
0 in degrees Fahrenheit is being substituted in for 0 degrees Fahrenheit was being substituted in for
yeah,
x. This 0
it's being substituted in for the whole
And
thing.
the
That's
whole
what I'm
f of x.
saying. So 0 equals.
Yeah.
Right. But we were still on this problem, and you jumped down to here then.
Oh, I thought, my bad. I thought we was.
I got you.
I thought, my bad. I thought we was on the second problem.
So we're here, okay? Now, before you start jumping in, Jakayla, I do want to pause here because Eli and I had an important conversation. You got to this equation, right? You got kind of stuck, Eli? What are you supposed to do to this equation?
Add on both sides.
No, before you get there, you're jumping into steps instead of looking at the bigger picture. Eli, what did we say we're supposed to do in an equation like this? Solve it. Trying to find what makes the equation true. Remember, when you have an equation like this, we want to solve it. We want to find the, what's the thing that makes the equation true again? Solutions. Right? And so, Jakayla, what were you starting to say?
Add on both sides.
Okay.
After you add it on both sides, you put it up, but you'll put it on 0, you break it down.
Hold on a second. Kenya, what do you think Jakayla means by add it on both sides? What am I adding?
Add your,
Kenya.
You're adding 4.55.
4.55. I'm not trying to shut you down, Jakayla, but I'm trying to give some people a chance to talk who haven't been talking so that they get used to talking.
I just need my point. So far.
You got your point so far. You ain't got to worry about that. Stop shutting other people down, right? We need to get others involved as well. You just have to be consistently talking during the whole class discussion. Okay?
Mark.
Now, I want to pause for a second. Kylie, why did I add 4.55?
You talking to me or her?
Oh yeah, you're right. Kylie Dunn, sorry. I looked at you and so I was thinking Kylie and then I forgot we got two.
You have to get the additive identity, so like the 0.
Oh yeah, what is that additive identity? It's what?
The
You just said
the
it.
additive identity.
Which is?
0.
0. Right?
Mhm.
So we added 4.55 to get that 0. Sharnavia, why did I add 4.55 on both sides of the equation? You're close. That there is something about equivalence. What's okay? So I'm going to use the property of equality, right, to create an equivalent So I heard over here, equation, right? I'm using the properties of equality to create an equivalent equation. So 4.55 is equal to 0.065x.
And now,
And now,
you get it by itself, so you got to divide by 0.065.
You get X by itself.
does anyone remember something I could do that besides divide by 0.65?
1 over
4.5.
Not 1 over 1 what? Divided by 0.065.
I mean, yeah.
So, does anyone remember what the name of this thing is?
Reciprocal.
The reciprocal, right? That's the multiplicative inverse to create the multiplicative.
Inverse.
No, it is the multiplicative inverse to create the what? Identity, which is. There we go. That's what I wanted to hear.
So if we did the other way, we alright.
You'd be all right, but
You just,
get used to that inverse.
If you get, well, on any assignment, do we have to do
it
that
just,
long?
when I do that,
Come on. Come on,
Literally, Kyle's talking, and like, Kyle's like, I don't care about you, Kyle, sir.
my bad. On worksheets.
yeah, on worksheets, on tests and quizzes, do we have to do that long way, or can we just divide? We take points if we don't show that part.
Is that?
Because normally I just divide it.
I know.
He want us to get learning to multiply fractions.
So,
That's-
Thank you for remembering, Anthony.
I mean, I'm just
Remember,
saying,
it's all about when you get to fraction coefficients, you need to know the reciprocal. It's going to make your life easier. I'm not going to take off, but I guarantee you, if you get used to doing the reciprocal here, you will be better off when it comes to those kind of problems. I'm trying to make sure that you develop good skills for long-term mathematics, not just short-term. So yes, you can do it. Now, I will say this. Do you know what you have to show me in order to earn 5.5s and 6s?
Yes.
What?
Work.
There's something here that you have to show me in that work, though.
Your word, that is true.
Say again? Yes, but there's a part of, this is justification, right? You can explain a little bit more, but there's some detail here that you have to show me in order to, not just the x.
The additive inverse.
No.
The solution for the.
Not just the
The
crossing
zero.
out.
The identity of
Identity.
each one.
If you just cross things out, you will not earn 5.5s and 6s. You've got to show me those identities, because the whole point is that we're creating identities. You just say, hey, I'm canceling things out. Yeah, you got an idea of what's happening, but not a full mathematical idea. But anyways, x equals what?
70.
Oh yeah, because does anyone remember what temperature the concrete was poured at?
70.
What degrees Fahrenheit?
70.
Oh, the concrete was poured at 70 degrees Fahrenheit.
I have a question.
So
Oh, yeah.
there was no expansion or contraction at that temperature. Yes, ma'am.
So, when you do the reciprocals and stuff like that, does that make it harder on me? Cause I be getting confused.
Short term, it makes it harder on you, but continue.
Okay,
It's just
it's
practice
always
and getting
gonna
used to it.
be, is it always gonna be the one over that x, the number?
The coefficient.
Yeah.
If you're talking about, so remember, this 0.065x, this 0.065 is understood to be divided by what?
1.
The reciprocal is always when the fraction flips or switches, the numerator and denominator switch.
So it's always gonna be a one though. It's never gonna be a different number.
If I had 3 halves x,
Yeah.
it would be what?
2 over 3.
2 divided by 3,
2 divided by
right?
Okay.
So that's why you want to think about that fraction, and then the reciprocal is when the numerator and denominator switch, because what is 2 divided by 2? 1, and 3 divided by 3 is 1.
And then it just gives you.
So it's giving you 1.
Okay, I'm gonna try.
I appreciate that, that's what I'm asking for. Okay, that was a lot more longer than I planned it being, but we'll just continue this into tomorrow, and we'll start the other thing tomorrow. But how would I, first off, it asks us to interpret the x-intercept.
Alright.
First off, I want to write first off, I will say this. You write your x-intercept like this, you will not get full credit.
No, the intercept is the temp is at 70.
Wait, what you just said?
Fahrenheit.
If you write your x-intercept like this, you will not earn full credit.
The 70 at 70 degrees Fahrenheit, the concrete didn't expand or contract.
That's a great interpretation, but no, your interpretation is great. I'm asking though, how should I write this x-intercept? The x is 70 degrees Fahrenheit. What am I missing?
You put it in Y.
Oh, I need an x and I need a y.
So it'll have to be 70 and 0.
Every intercept should always be written as a point. If it is not, you don't have an x-intercept. Technically, does anyone know what x equals 70 would look like on a graph?
Nope.
Not just a straight line, it would be a,
Up and down, X, right there, it's
that would be a vertical line, right? That's why you can't just write x equals 70 because that's not a point, that's a vertical line.
And Y, if Y equals something, it'll be horizontal.
Correct. Which is why, again, we need to write it as a point.
Point.
Make sure you write your intercepts as points. Anthony, say your interpretation again?
At 70 degrees, the concrete didn't expand or contract.
Meaning that the expansion or contraction is 0
0.
feet, right?
0 feet.
Notice how we have to get our x and our y in there.
This is a random question.
I might have a random answer. Go for it.
How many questions did you find out?
My what?
How many questions did you find out?
I have no idea. It changes every year, every semester when I teach it.
Hey, some people already have this planned out.
I know. But there's this weird thing where I adjust according to like what my students need, and I teach it slightly different every semester to meet those needs. I hear what you're saying, but just be aware I'm not.
Because all of us.
I will have some questions that I already have done because of what I did last semester, but
Lightfoot, oh my god, 200?
Oh,
well,
yeah.
first off, my final will not be multiple choice, and it's not just like words.
Wow.
It's gonna be like this.
Can you take it?
Am I teaching this? Are you learning this?
Kind of.
Kind of. So we got to do that, all right? So I think that's a good interpretation. But when you logged in, you should have all already had a copy of your linear modeling file on your calculator. So does anyone know how to access documents on the calculators?
Go to browser.
Okay, so go to home, hit home, go to browse. So yeah, you're in Algebra 2 Stats Spring first block, so hit enter when that's highlighted.
Documents or linear model.
Oh,
Linear
wait.
modeling.
What did you say, Joe?
You're in Spring first block, and then hit linear modeling, and that should be the file that you had when you ended class last week.
Well,
Maybe it's
mine
low.
say empty folder.
Let me see.
Is you logged in?
What you got going
I
on?
don't know.
It should. I see Omar's there. Let me see your Spring first block.
Their spring first, or her spring first one is there.
Oh yeah, because you weren't here. Alright, let me resend it out. I'll redistribute. Alright, for those of y'all who were not here for it, you should be getting it right now. So I sent it to the missing student, or students who are missing it. Click open when it says transfer is complete. So what we should be on is 3.1 at this point. Okay?
Okay. It's getting easier and easier, but like I still be missing some details.
I mean, here's the thing I want y'all to hear, and I like the way Anthony's saying this, it's getting easier and easier. It's not about having it perfect right away. It's about the growth. When you think that you're supposed to get it right away, you're going to mentally frustrate yourself in my classroom because you're not supposed to get it right away. It takes practice. It takes thinking, and it's gonna be okay. All I ask is for you to put in the work to grow. Alright? So, understanding data in context, task 3 is application of linear modeling with a fair amount of data scattered. So, what you have already in your calculator is data on the Earth's average global temperature for the last century. And I'm not getting into the political side of whether it's man-made global warming or just natural global warming or anything like that. But what you'll see is that the temperature of Earth has slowly increased over the last century. And we'll see that in this data. So data has already been loaded. Data was recorded every year since the start of the 20th century. And each data point represents the number of years since 1900. And the temperatures are in degrees Fahrenheit above or below the average temperature, right? So what they did is they took the temperature of, or the average temperature of each year, and then they averaged all those averages, which gave us our 0. And they figured out whether the temperature was above or below that, okay? And so I will say this, the reason why I say I'm not getting into the political side of it is I am providing you data and the ability to think, and then I want you to make the conclusions on your own. Do the research if you want to look more into it. But it's not my job to tell you what to think, it's to teach you how to think, alright? So, once you have zoomed to see your data, which those of y'all who missed part of last week, talk to the people within your group to figure out how to zoom to the data. It's very simple, and I'll be coming around, and so will Miss Courtney. Oh, by the way, for those of y'all who missed last week or have not met her very well, this is Miss Courtney in the back. She will be with us until end of April as an intern here every day, except for days that they pull her out to do stuff at UA. So, follow these directions, transform the slope and things like that, and do the same exact stuff that you just did on the previous task, which probably means we should have that out so we can practice it, right, Anthony? Because that's what we need is more practice. Let's get to work. Yes, sir. Because there's, how many years are there in a